questions you have now on the homework, I'm happy to go over any of them.
I have a question.
Yeah.
If you have ln x within a trig parentheses,
Yeah.
and it's divided by ln x, there's no way by that one, right?
No, like, okay, great question.
Like in which one?
Like you're kind of looking at 4.
Okay, we should do it. What is the little star for on the slide?
I don't know. Let me see. Which one did I star?
I didn't know if you could have an L inside of it.
Oh, yeah. So, like 3 and 4 are actually pretty important with the ln problem. So let me look at 4 first. 1 over x. Cosine of ln.
Yeah, 3 was kind of weird.
Okay, for number 4, first of all, let me just back up and say, if you had the integral of the cosine of ln x dx, it would not equal the sine of ln x divided by ln x plus c. You know how, like, hold this up too, the integral of the cosine of 2x will equal the sine of 2x divided by 2 plus c. If you have trig, right, and it's anything other than just like cosine of x or sine of x, okay. As long as that thing with x is a constant, you can just divide by it and be done. But if that thing is something else, like it's its own function, you can't just divide by the natural log of x. You've got to be crafty and do something else with it. So, do you get that? I can't do that. And I can do that when it's a constant. So this particular problem, if I had just this, it would be undoable. You wouldn't be able to do this problem. But I can do this one, because if you pick u to be the natural log of x, well, the derivative of that is 1 over x dx. So that's why they put that in there, so that you'd be able to do it. So that you could turn this into the integral of the cosine of u du. The 1 over x dx is your du, and then the ln x is your u. Got it?
So,
And then, but wouldn't that just be sine of u over u, and then you plug in ln x and you have the same thing you have?
No, it wouldn't be over u. It would be sine of u. Period.
Oh.
The only time you put it over anything is if you have a coefficient in front of your variable.
Oh, right.
Then you put it over there.
So, does that mean that the answer to the bottom one would be x on the numbers?
This one, like, I don't think it's doable. You can't do it.
Will you ever give us one that we can't do and just mess with us?
I don't think so. Yeah.
Are you thinking about problems like number 5, where there's actually no substitution needed?
Yeah.
That's really hard.
I know. Yeah.
That was pretty crafty.
It worked though. It's not
What's going with 8? Actually, before we do 8, should we look at 3?
No.
Because I started.
Yeah, I'm sorry, go ahead.
You sure?
Yeah, I have a question on 5, but
Okay. So just because we're on like the log thing, let's go to 8. I mean, let's go to 3. 3. Markers stink. Can you guys see this? Can you see these okay? This number 3 would be a lot easier if it was written like this. I don't know. I think it would be a lot easier if it was just written like that. Maybe it's a little bit easier to see. But what I did was I picked u to be ln x because what's the derivative of the natural log? 1 over x dx. And if I look at it that way, well then u is right here, and 1 over x dx is my du. So this just ends up being 1 over u, and then that stuff is the du. And then I can integrate. What's the integral of 1 over u? Remember, this is the u to the first. If you bring it up and make it -1, that should be your clue that like something's that you're wrong. because if you add 1 to negative 1 and get 0, it screws the whole thing up. So the integral of this is the natural log of u plus c, and then put u back in, so it's the natural log of the natural log of x.
It's a weird graph.
Yeah.
You can grab that, but it is.
Yeah, I mean, you can graph anything. I just, well, almost
Anything?
not anything.
I have a question.
Yeah.
Well, in number 2, since 1 minus sine x can't ever be negative. Because sine x can never be more than 1.
Sin x is between negative 1 and 1. So, yeah. So, do I have absolute value bars?
Yeah.
You don't need them.
Wait, what if
But
you
you'd
have
need
them and you don't use them?
What's that?
Might as well.
You need parentheses, so. But, yeah, you don't need them.
If you have them and you don't need them,
That's fine. I would just always put them. Yeah. Just you might see the answers without them because they're being like all, I'm so smart, you know. Alright, number 8, did someone say?
Yeah.
Do you need the absolute value bars there?
There. The natural log of x can be negative, so yeah. Yeah. E to the 5x squared minus 1. Yeah, I did. I just right there. Huh? Done. So gross. I couldn't see, okay? I'm getting old and I can't see my paper. I need like reading glasses.
Yeah, I don't think pooping to that.
I did poop. I made a funny, whimsical sound with my lips. Alright. What? Whimsical? It's a good word. So what would you pick for your u? 5x squared minus 1. Alright, so if I pick that, then du is going to be 10x minus 1's gone. So then this means I need a 10 in with my x, so I need a 1/10 to make up for it. So I've got 1/10 times the integral. 10x dx is my du. This becomes e to the u. So the integral of e to the u is e to the u. So we got e to the 5x squared minus 1 over 10. Oops. Yeah,
Once we learn other methods of taking the integral other than substitution.
we only have one more.
What's
there's
that?
only 2 then?
Well, there's only 2 that, like, in the context of this course,
Oh.
but
There are more?
not really, actually. There's
Let's learn them.
got to be, like, a couple more, like, crazy advanced things.
Teach us those.
No, we don't have time to get to it.
Please go.
Well, there is double substitution.
Mike.
Really? I hate you.
Yeah.
So on number 5,
Uh-huh.
when you said we don't need substitution,
Right.
if you do substitution,
I
do you
don't
get the
think-
right answer anyway?
Mm-mm.
You don't?
I don't think so.
Because I use substitution. Didn't you say yesterday?
Wait, I got it. I got it.
Yeah,
You
is
did?
negative
I got
ln
it.
cosine x equal to ln, or what's the answer?
Yeah. I did it. I did it.
Really?
Yeah.
Yeah, I got
Must've been really
negative
complicated.
Cosine is u.
Yes.
So you said cosine was u.
Suggest.
After you then substitute, then did you split it up into 2 separate fractions?
I think I did split it up.
I did like.
You think?
Didn't you get like a du minus u over u?
Yeah, I did, and then I took
That's
out
intense, isn't it?
a negative 1, or no, then I split it up into du over u plus negative u over du.
Oh,
and
like
I got
minus
du over u
1.
minus 1.
Ah, alright. There you go. That's weird.
But wait, should that not work?
No, well, I think it's just such a weird
Hey.
case. It
Plug in
works.
for-
Zach, seriously, get your freaking hands off of Kara, I swear to God.
Bite me.
Oh my God.
Frisky. What are you doing?
I was like, sorry.
I don't think I made any motions or noises like that.
Sorry. I'm sorry, I just needed an outburst. Did I tell you I was in Such a frazzled mood yesterday. I ran over my lamppost in my yard.
What?
Wait, you ran over
Why?
your
Right. It's not standing anymore.
Were you backing up or driving forward?
Backwards.
Oh, you have a lamppost.
How's your car
already.
looking?
Okay.
I don't honestly. I haven't even looked. It was yesterday, and like I've been so busy, and I forgot that I did that. So yeah.
How big was this public?
Like when you said lamppost, I
Oh.
thought you have in your house.
No.
I'm wondering why you have
No,
one
like
in
an
your
outside
yard and why you
lamppost.
ran over it.
Lamppost. 10 feet
Wait,
tall.
does the light still work in these?
Oh.
Because that'd be awesome.
It was like,
Did you?
I didn't bring any Christmas lights though. We had them like lined on, like Christmas lights lined in the driveway, and I backed up over the Christmas lights and knocked over the lamppost. All Christmas lights are intact. Lamppost, 45 degrees.
Did you?
Did you get any mailbox?
Wait, did you like
No.
completely run over and just keep going, or?
No, I stopped.
Oh.
Yeah. I considered driving around the other side and trying to run over the other way and head straight again, but I didn't. I called my husband, I'm like,
So how's your
remember that
car?
lamppost? I hope you didn't have any like big connections to it, because it's not good.
How's your car though?
Oh, it's because my kids are driving me crazy.
Why?
Because they were just like fighting, and I'm like, I just said goodbye, and I ran out the door. I left them both inside crying. I just spit all over my desk. And then to warm up the car, and then I ran back inside, got them, ran back out to the car, and ran into a lamppost. Oh, there's the blue marker. Okay.
This video is totally going into a custody hearing.
Alright, so we have a couple things to go over. Would it be helpful to you to have in all one place, like all the derivatives you should know?
Yes.
Yeah.
Now, would it be more helpful for you to write it yourself?
No.
Probably so I can write it.
Well, if you write it and then we write it based off of your writing,
I already wrote it,
but you should write it again.
but I didn't photocopy it.
No, photocopy it. Wait, what is this?
It's like all the derivatives you should know, all the trig stuff, all the
Yeah.
natural logs.
Just make us write.
We need
I
that.
want that.
Just start writing. Don't say anything else.
No.
Well,
Or go to the
here's the one you
library
need to
and
remember for today, because I just have a couple of kind of random examples.
That's that worksheet.
What?
The worksheet.
She has a photocopy.
I didn't photocopy it yet.
Let me go photocopy it right now.
Yes.
It seems like, then you're going to miss the notes.
We can wait.
Alright, when you were done the notes, you can go photocopy this while we like start working on problems. Alright. So, one thing to remember is, do you remember what the derivative of the arctangent was?
No.
No.
It's like
something weird.
Ooh.
Wait, yeah. Well, I'll still make it X for here. Just 'cause it just looks
Pretty slammed.
nice job. Steve?
It's almost Friday today.
Oh.
It's about the smartest thing I'll say all year. Asking my board.
What are we doing tomorrow?
Taboo.
You know what I think we're gonna do tomorrow?
Taboo.
No, I think I'm gonna do an actual, like, old school group task.
for points.
Yeah.
All right.
Oh,
I'm not working with Mike.
I'm not working with Mike.
I did them too, so you would have hated me too then.
Can you like randomly assign groups?
I'll come up with an interesting way to assign groups.
Hell no.
You should not assign groups.
Can we just
Only
like
BBG.
Bring food in and we can eat it.
There's gonna be an inequality.
You do that tomorrow, I'm gonna freak out.
I know, and I just think that this stuff's too important to go too fast, and I just want to like do a few problems and just see how they go and
We
stuff
need
like
a day
that.
off in real life.
I like it.
No, I just
It's
you
not
always
like
like
your
check.
task.
What?
You always like check our group tasks.
Did I what?
You like to check our group tasks.
Yeah, I know. All I wanted to make sure was that you knew how to do it. I don't care about grades.
So we all get A's.
You're like hardly ever gonna see inverse trig go backwards, except for arctan.
Oh,
So you could see the integral of dx over x squared plus 1 and have to realize, oh, that's arctan.
yeah, I'm sure no.
And you just have to know it.
Yeah. So think about a problem like this. How else would you integrate 1 over or dx over x squared plus 1? I mean, if you picked like u to be x squared plus 1 well then du is going to be 2x, but I don't have an x in the problem.
Then you divide by 1 over 2x and put a 2x on the
Can't do
outside.
that. So if you have 1 over, u squared plus 1 or x squared plus 1, you're going to have to use arctan. Here's an example. Because they're always going to throw like a weird number in there. I forget what the problem was. I don't know, maybe something like this. Let's try this one. Okay. If you saw this, yeah, you would cry. There's no way to do this with substitution. There's no way to split up your fraction. So let me say this: if you had that, you could do this by substitution. I just kind of want to make it clear of what you can do and what you can't. This you could do by substitution. You can make u equal to 16 plus x squared, and make du 2x, and you can like manipulate this to be a 2x. So that would be doable. You also could do it if it was upside down. So if I had that same thing but it was upside down, I would split this into 4 plus x squared over 4 and do them both separately. So I'd get like 4x plus x to the third over 12 and multiply. Do you know what I mean? It's like those two are totally doable. If you have this in the bottom and there's an x on top, I can do it with substitution. If it's this way and I can split it into 2 fractions, I can do it whatever, like the way we've been doing it. That, I'm stuck. So you need arctan. The problem is, arctan looks like this. And that's not quite what I have. First of all, I have a 4 on top. Now that's not a problem. I can rewrite this as 4 times the integral of 1 over 16 plus x squared. Yeah, do you agree with that? I can take any constant and bring it to the front of the whole thing. It's not going to change the value of it. But I don't have this yet. I have that 16. I don't have x squared plus 1. I have x squared plus 16. Okay, ready for this? I'll put my dx up here just because it's a little easier. I'm going to multiply the bottom by 1/16. And multiply the top by 1/16.
That's cheating.
Okay, I haven't done anything illegal. I'm just multiplying by 1. Because on the top that's going to give me 1/16 dx, which I'm just going to pull that out in a second. And on the bottom it'll give me, I have to distribute, so it's going to give me 16 over 16, so 1, plus x squared over 16. You might think, we didn't really get any closer. We fixed the problem in getting that to be a 1, but now this isn't just x squared, it's x squared over 16. But, well first I'm going to take the 1/16th out, okay? I'll do all the steps of this so that you can see it all in your notes. Okay, this is just another constant on top. I'm going to bring it out. If I want this to be like arctanable or integratable with arctan, I literally need it to be x squared plus 1 or u squared plus 1. I don't have that yet. But I can rewrite this again as 1 plus x over 4 squared. And I can use substitution and make my u equal to x over 4.
No.
It's not a lie.
Yeah, this is bold.
Well, the problem is, if u is x over 4, I have a du of 1/4 that I'm going to need to insert in. So without the u, you've missed that little like 1/4 thing. Now you're always, like, I'd say 90% of the time, this number is going to be a perfect square. So when you like multiply by 1/16, you're going to have this x squared over 16 that you can rewrite as x over 4 squared. If not, if it was like 15, I'd have x over root 15 quantity squared. But most of the times I've seen it, this is a nice perfect square. So, if du is 1/4 dx, well, I need to insert a 1/4 and therefore multiply this by 4. So I ended up with, I'm going to keep writing the fraction just so you don't think it like magically disappeared. I end up with 16 over 16 du over 1 plus u squared. And now finally I have it in the form it needs to be to integrate with arctan. But you have to be really specific. It's got to look exactly like that to work with arctan. So all I did, I just did a ton of manipulation to get it to that point. So in the end, 16 over 16 is 1. The integral of this is arctan of u plus c. So it's arctan of x over 4 plus c.
Could you also simplify the 4 over 16 to 1/4 and not have to do that?
Wait, say it again?
Yeah.
Oh yeah, totally.
Okay.
I could have simplified this to 1/4 and just stuck it back in and never had to do that substitution, but that was a lucky. It's not usually gonna do that.
Okay.
It's weird that I ended up with 1. That doesn't usually happen. Do you see everything I did? I'm sorry. Okay, so that's one thing that's newish.
Are we done?
No.
My brain's done.
Whee! I got 2 more things to show you actually.
Are they all that long?
One more.
They're not all that long though. No. Just 2. Let's see, what do I want to show you? These are like gifts that I'm giving you. Yeah. Okay, so we just haven't done this yet, where we actually have limits of integration. It's where it's a definite integral. Everything we've had has a plus c on the end, so now there's no plus c. There's like a little shortcut to show you. So it's not that big of a shortcut, but it's actually important. We start off just integrating this like normal. What would you pick for your u?
Secant x.
If you pick secant, well, I guess it would work.
Yep.
I guess it works either way. Because if I pick secant, then my derivative will be secant tan, and I'll have that.
Yep.
Huh, interesting. I was going to pick tangent.
No.
Because the derivative of tangent was secant squared, so I'm going to go with what I felt like doing. I feel like it's a little easier, but yeah, either way would work. So now I've got the integral of u du. But here's the trick. Once you switch into a new variable, so once I move away from x's and insert u's, my limits of integration change. Because in the original problem, the limits of integration were in terms of x's. But once I change to u's, the limits of integration should be in terms of u's. So I need to change these accordingly. So to do that, I'll say, well, when x equals 0, what does u equal? And when x equals pi over 4, what does u equal? Why did I pick 0 and pi over 4? Because that's what's already there. So when x equals 0, u is going to equal the tangent of 0. And what's the tangent of 0?
0.
0. And when u equals pi over 4, what's the tangent of, I'm sorry, when x is pi over 4, what's the tangent of pi over 4?
1.
1. So my new limits are going to go from 0 to 1. And now I can just integrate. The integral of u is u squared over 2, and that's just going to go from 0 to 1. I never have to put tangent back in. So if it's a definite integral, especially with all the trig and all the nonsense, if you can get it to work by substitution and replace your limits of integration, it's actually a little bit easier. So if you plug in the 1, we'd have 1/2 minus 0. Our final answer would be 1/2.
What if we're put the tangent back in?
Yeah. So if you do it, if you didn't know that, right, and you never replace these limits, and you got u squared over 2, you put tangent back in, so you'd have tangent squared over 2. Then I would evaluate from pi over 4 to 0. And well, the tangent of pi over 4 is 1 squared, so we'd still have the same thing. Do you understand? So if I do it without knowing to change the limits, it'll still work. The difference is this. On the AP test, they love to put a multiple choice problem down where they'll say, what is the u substitution you would use for this problem? And then they'll list a bunch of answers. One of them will be this one, and one of them will leave it as pi over 4. And that's the wrong answer. Because once they change it into u's, you've got to change the limits, and if you don't change the limits, then it's technically wrong. So that's why it's worth showing you. They're going to try to trick you.
Isn't it technically about it?
What's that?
Isn't it technically about it?
What do you mean? That you're technically wrong? Oh yeah, so you're wrong, period. Okay, so that's why it's important to go over. When I first started teaching this, I was like, I don't need to go over that. What's the point? Just put it back in terms of tangent and evaluate it. And you can, and that's fine. But if they ask you a multiple choice question like that, you'll mess up if you pick that one. So that's the idea. Is that okay? I have one more thing to show you.
No, you don't. No, you don't.
Do you feel like really overwhelmed?
No, but I just don't want to do anything. Silent ball.
No, then I'm going to show you. No, sorry, I'm doing it. Yeah, sorry. It's an in-class post.
We have a study hall test tomorrow.
I'm on your way.
Terrible idea.
I can come get you.
Who wanted to test on Monday?
Maybe they're anywhere.
What a punch in the
I
face.
can get you.
Dude, you want?
What?
She's on right. You do know she's like right on the way.
Well, I was trying to make you jealous. So you
Rosie worships me.
That would make
Why?
Oh, really? So it's okay if I go and pick her up?
that would be so mean. It's called sneaking right makes me go and we don't.
Okay, we get it.
Oh, show somebody who's like not in these classes your notebook sometime. They're gonna be like, what is that?
So we do it.
Okay. So that's why I thought today was a good day to do a couple of these little things because none of them are so crazy hard, but they're just worth going through together. So this is a separable differential equation. We've already done this, right? These are the ones where you got to separate the variables, integrate both sides, plug in to find c, and then solve for y. This is the one in like the open-ended question where it's like 5 points, and if you don't separate the variables, you get 0 out of the points. So we're going to do it the same way. It's just that the integration's a little more challenging than it has been so far.
E to the x squared.
It's e to the x squared, yeah.
Beautiful.
Yeah. So the first thing we're going to do is what? Separate the variables. So dy
Wolfram alpha, so you get the answer.
will be over 1 plus y squared. Whoops.
Oh, that one.
And then we're going to have why is wrong? 2x e to the x squared dx. Okay. variables.
Point.
Now I have to integrate both sides. Does this look familiar?
Arctan.
Arctan. Okay, it's already set up for you nicely. I can't imagine in a separable differential equation problem they're going to give you anything other than a simple arctan that it wouldn't get, like with that weird thing we did do last time with the 116. So this is just arctan. Be careful because it's arctan of y. And now on the other side, it's not just a simple integration problem. It requires substitution.
Not really.
What would u be? X squared. Okay, u is going to be x squared, so du is 2x. Again, it's pretty simple because I don't even have to insert anything. So I will just rewrite this as the integral of e to the u du. So we get arctan of y equals the integral of e to the u is e to the u, and I'll put u back in. I'll put my plus c on there because I don't want to forget it. This is, okay so far?
Yeah. So you just use slap on a tangent.
Yeah, they didn't give you an initial condition. If they did, if they said it went through the point, you know, I don't even know, 0, 1 or whatever, you would plug in 0, 1 and find c now. Okay, do it now. Don't solve for y first. It just makes it harder. So if they give you a point, plug it in now. They didn't, so we're not going to plug something in. And then once you get c, put c in and solve for y. So to solve for y, we're going to take the tangent of both sides. That's the whole idea with arctan, is it's the inverse of tan, so tangent and inverse tan undo each other. So if I take the inverse, if I take the tangent of both sides, I'll be left with y on the left equals the tangent of e to the x squared plus c.